Hey, how's it going? I'm your host, Gerhard, and you're listening to Ship It, a podcast about getting your best ideas into the world and seeing what happens. We talk about code, ops, infrastructure, and the people that make it happen. Yes, we focus on the people because everything else is an implementation detail. Chaos engineering is not just for super SREs. It is not meant to prevent outages. And it is not just about hardware. Chaos engineering is about testing how reliable your systems are. It's meant to show you how things fail, including when other dependent systems fail. Think cascading failures. This is a great way of discovering many inconvenient truths about that beautiful code that you wrote. Today, we will be learning about chaos engineering from Uma, CEO and co-founder of ChaosNative, and Karthik, CTO and also a ChaosNative co-founder. Litmus, which is chaos engineering for your Kubernetes, comes up. Big thanks to our partners Fastly, LaunchDarkly, and Linode. Our bandwidth is provided by Fastly. Learn more at fastly.com. Feature flags powered by launchdarkly.com. And we love Linode. They keep it fast and simple. Check them out at linode.com/changelog.
This episode of Ship It is brought to you by Render, the zero DevOps cloud that empowers you to ship faster than your competitors. Here's Anurag Goel, CEO of Render, sharing why developers choose Render over Heroku and how they're innovating much faster.
A lot of Render customers come to us from Heroku, and they tell us Render is what Heroku could have been. I think it's because we offer a more streamlined approach to hosting modern cloud applications at a significantly better price point. Applications on Render heal themselves and scale automatically, giving developers the features and flexibility of something like Kubernetes, but without any of the complexity. We're always working to bring the latest industry advances to our platform, so your applications can leverage the state-of-the-art in the cloud without you having to do or learn anything.
All right, learn more about how Render compares to Heroku at render.com/compare or email changelog@render.com for a personal intro and to ask questions about the Render platform. Again, that's render.com/compare or email changelog@render.com.
We are going to ship in 3, 2, 1.
The network is not reliable, right? And those that think that it is, they will be in for a surprise. Unless you've had some network outages or some packet loss, or even like at your home, you always think it will work, right? There won't be any problems. Well, it doesn't work like that in reality. Disks fail all the time. The more infrastructure you have, the more you realize how just often disks fail. CDNs fail all the time. In episode 10, we talked about how Fastly failed for a few minutes and half the internet went down. That was an interesting one. So how do you know that the beautifully crafted code that you ship continuously, it's test-driven, it's beautiful, it gets out there, how do you know that it will continue serving its purpose when failures happen? Because they will happen. I think, at least in my mind, that's where chaos engineering comes in. But what is your perspective, Uma?
That's right. Chaos engineering, it was being viewed in a little bit different way earlier. It was purely for stopping the outages. The SREs were tasked with, I tried everything, but now can you do something new? You are a super SRE. So, okay, let me do chaos engineering. But I believe it's changing, right? Chaos engineering is a little bit more than a tough piece that is meant for super SREs. Now, chaos engineering is more of a good and easy and a must-have tool for DevOps, as long as you're trying to improve something on reliability. Yes, you're right. It's about reliability. Nothing is reliable, not just networks. Almost anything that you deal with, if it is software, is unreliable. It is reliable to some extent, but not 100%. So I believe chaos engineering is still an evolving subject. and it has evolved in the last few years from being purely a fascination for an SRE as an expert subject for an SRE into more of must-have, good-to-have tool for all sorts of roles, ranging from SRE to all the way to developer. That's my observation recently.
So, okay, chaos engineering is important. It's an evolving topic. It's, I think, a field that changes quite a bit, right? It's chaotic, pun intended. So why is it important, Karthik? Why is chaos engineering important for shipping code, writing code? What is the link there?
I think you mentioned about Fastly going down for a few minutes, and that took half the internet down with it. And I'm sure it would have cost a lot. Downtimes are extremely costly. You would want to avoid them dearly. And there is, I think, enough motivation for you to test how reliable your systems are. And it's like Uma mentioned, it's not something that you only do in production, though that is where the benefits of chaos engineering has been most realized over the last decade or so. But it is important that you go ahead and test your systems, because there is so much changing there in your deployment environment all the time. In today's microservices world, the application that you're deploying in your deployment environment, it could be Kubernetes, or it could be somewhere on the cloud. There are so many other moving parts that you depend on to give you that wholesome experience for the user. Things that help developers support SREs, and things that are viewed by the end user. There are so many components in the deployment environment which cater to different audiences, help running the entire system. It's possible any of those components may go down, relying in varied degree of degradation in user experience. It could inhibit your support team from serving customers better, or the customers might have a direct impact not being able to use your service. And that is something we would want to avoid. And chaos engineering is a lot about learning your systems as well. Many times we assume certain infrastructure aids while developing code, which turn out to be untrue when you're actually deploying it, and you really want to know what's going to happen when things fail in the infra side. So yes, I think that is really about chaos engineering as to why that is important.
So taking that, how do you chaos engineer a CDN? There's just one that you have in your system. How do you apply chaos engineering principles to test the resiliency of your CDN? Can you do that even?
I think ultimately you would host your CDN on infrastructure that you're either putting on your own data centers or on the cloud. So ultimately anything that's powering software is ultimately built on some platform. And you could go ahead and start off by checking what happens when something fails in the platform. It could be a disk, it could be a network, it could be some resource exhaustion that you're seeing in the platforms that is hosting the CDN. And I'm sure when you're building the network, the data network, you're still ensuring that data is spread across different machines, different regions or areas, and you're somehow building some amount of resiliency into how the data is served, retrieved, and served to your end users as part of a CDN. So you can check the extent of high availability that you have built in by targeting some very simple infrastructure faults. I would say that would be a good starting point.
Okay. What do you think, Uma? Anything to add?
I mean, CDN, it's a complex topic. Which part of CDN you're talking about? At the delivery, your networks need to be reliable. Your supporting infrastructure need to be reliable. And the software that runs CDN need to be reliable, right? So the idea of applying chaos engineering to your CDN is to improve something that's already mostly reliable, right? Today, the CDN is reliable. We all work on internet, but it is it's services like Fastly going down once, or you in a year or even less often.
Yeah, first time in 5 years for us.
First time in 5 years for us. And we took that and we are saying that, hey, something has happened. How do I apply chaos engineering to it? In reality, it's not that simple, in my opinion, right? Site reliability itself is an engineering. Chaos is an engineering, right? So engineering comes with understanding what's going on, and there is no unique way of saying that this is exactly how I'm going to fix it. It is going to depend on what is the problem in that given situation. So I would say you can apply chaos engineering not just only to CDN, to any other system, but really looking at the way the services are architected or deployed, and look at the services and see, is there something that I can see as a low-hanging fruit that's either doubtful about reliability, or it's constantly causing me trouble. Let me go and attack that, debug that, right? So then the one way to debug that is, can I actually introduce a fault and see, right? So you need more ways of reproducing the faults, and then you go and go to your SREs, or SREs generally go and try to fix up quick recovery points, or try to avoid that dependency on that failure. But really, you need to go back to developers to really fix the root cause of it, right? So if you ask me to summarize the whole chaos engineering for CDN, it needs to be at different levels. Infrastructure again is storage and network. If I recollect some of the scenarios that I heard of, it's always about a slow storage that caused more of a bigger issue all of a sudden, and it never happened, the storage slowness, right? Or networks usually are very tolerant in terms of faults, but still, like double, triple faults can happen. So one is about verifying how reliable is your infrastructure dependency, right? So try to introduce some slownesses intentionally and keep verifying your CDN continues to work. And that's one level. The other level is take a look at your services and how reliable you are. And then if networks go slow or storage goes slow, do you have software that is reliable enough to switch on to something else, or do something that's more proactive to keep continuing to serve the data? So as I said, it's engineering, and that's why we need good tools for site reliability engineers. That's chaos engineering.
That makes perfect sense to me. So if I had to summarize what chaos engineering is in one short sentence, to me, that would be the injection of artificial faults. They're not real, they're artificial, they're made, we make them to see how the system as a whole reacts to those artificial faults. Would you refine that, add something more to that? What is it? What is chaos engineering to you in one short sentence?
I'll probably take a crack at it, and I think Karthik can give probably a better answer. I usually separate chaos and engineering as two different words in my mind. Right? People always think chaos engineering as chaos. To me, it's easy to introduce chaos. Of course, you have no better tools. It's faster to introduce chaos, but I would give more preference or more importance to the engineering side of chaos engineering. It is always about what should happen when you introduce a fault, right? A very simple fault, a very simple service, if it fails, how you react to it is always well tested. Your dev, QA, SREs, user acceptance tests, we are living in the modern day. All our systems are very modern. So, but failures do happen because something unexpected, untested has happened, right? And now we are looking at chaos engineering as a way to unearth those faults in a willful manner, right? So what is chaos engineering in that sense is when a fault happens, what should you look for, right? How do you actually search for a fault, right? So that's the steady state hypothesis. right? If you go and look at what is my steady state, you can look at just one service or look at many services together. And if you define the steady state hypothesis that is closer to your business or a business loss, then you will come to chaos, right? So, and the tools and the strategy design should go towards thinking more on the engineering side of, how can I avoid a certain loss, or how can I unearth a complex scenario or a complex faulty scenario, and then I can split that scenario into multiple chaos stuff, and then that becomes easy actually. So
Yeah.
it's engineering. That's the way I look at it.
I'm really looking forward to Karthik's question. But before that, I would like to ask you, Uma, how do you look at a system? How do you look at the steady state of a system? What do you use?
I would generally define the system in the minds of people who are the persona that are using, and what keeps SREs and the management of the SREs up at night, right? So it's something that is closer to business criticality, the service, right? So that's what the system to me is. It is not really about the technical stack, and technical stack comes later. That's where we introduce chaos. But the system really is about service and service catalog, hierarchy of services, dependency of services. This is what the system is. So I would go ahead and define that map and identify the criticality points. And then I'll start thinking about, manually, if I introduce a fault, what all will shake up, right? What can loosen up, or what can fail, and who will wake up first, right? Before the customer starts screaming too much. So that's what is the system in my view, where you're going to apply chaos engineering on.
So what I'm hearing is that not only you need to know all the services that make up a system, but also what does it mean for end users to be happy when it comes to using that system. So you define all the services that make the system, and also what does healthy mean for every single component in the system. And that is your steady state, right? Steady state is define what happiness means for your end users. Capture that somehow. I imagine dashboards, metrics, logs. No?
Yes, again, it depends on how old or structured the system is. It's really about good dashboards if you have, and you're using good service level object scheme, then you have a system that you are looking at, right? And if you're only measuring how often the faults are happening, and if you're really depending on how happy my customers are as a metric, generally to rely on how reliable your systems are, then you're in for a surprise. Yeah, you should have a good schematic of the service level objectives.
That is a great answer. Very complete, a lot more comprehensive than I was expecting, but it was very, very good. Which comes back to Karthik. And the question was, I know we talked a lot, so let's restate the question. The question was, what is chaos engineering in one short sentence?
Yeah, I think we are living in the times of the pandemic. So let's call it injecting harm to build immunity. Just that instead of injecting harm into human beings, you're doing it on systems. So I would define chaos engineering as that. And Uma made a great point about steady state hypothesis. I think when Netflix and Salesforce and Amazon, all these folks put together the principles of chaos a long time back, they made that as the central piece of the discipline of chaos engineering, along with recommendations to try different kinds of faults and run chaos continuously, because you never know when the system behaves in what way because of what change induced into it. So yes, I think chaos engineering is a lot about scientifically trying to understand or mapping user happiness to metrics and logs and events. Steady state can be very diverse, and today's age that diversity has just increased. You could be talking about metrics, you could be talking about the availability of some downstream service, or it could be something on your clusters. So you're talking about resources in Kubernetes. It could be the state of a resource. And there are custom resources that extend the traditional Kubernetes capabilities to a lot of domain-specific intelligence. So being able to validate that info is also part of steady state. So I think, yes, chaos engineering is about willful fault injection, like you mentioned, Gerhard, artificially inducing faults in order to verify how the system is behaving and have good means of identifying the deviation in steady state and checking whether it is within tolerable limits or no. And then it's all about doing it continuously by going back to the drawing board, fixing your application business logic, or maybe your deployment practices, coming back and repeating it, and thus proceeding with the next possible outage that you can think of.
What's up, shippers? This episode is brought to you by Sentry. You already know working code means happy customers, and that's exactly why teams choose Sentry. From error tracking to performance monitoring, Sentry helps teams see what actually matters, resolve problems quicker, and learn continuously about their applications from the front end to the back end. Over 1 million developers and 70,000 organizations already ship better software faster with Sentry. That includes us. And guess what? You can too. Ship It listeners new to Sentry get the team plan for free for 3 months. Use the code SHIPIT when you sign up. Head to sentry.io and use the code SHIPIT.
This doesn't happen often, but I was talking to one of our listeners, Patrick Fio, in Slack, and he has a question, or like a suggestion, which I think is a very good one to bring up in this interview, in this conversation, this episode. Patrick is saying that he would love to hear about practicing inefficiencies or applying non-best practices in small doses. I know it's not exactly the chaos engineering that we discussed, but I can see an overlap between doing the wrong thing on purpose and chaos engineering. What do you think, Karthik?
I think it makes sense. And I think this is especially true when you're trying to find out rather how good your security systems are. There's an entire new category of, or a subcategory within chaos engineering called as security chaos engineering, where people are trying to find out how reliable their systems are in terms of security by introducing some vulnerabilities deliberately. And I can relate a lot to Patrick when he says running things in the non-best practice way. You can run privileged containers, mount host paths, and basically try and see how your system behaves. Is it being called out? Do you have the right policies that restrict you from doing so? These are things that you would want to find out. And not just for security. I think that's probably one thing that comes to mind straight away. But even for other scenarios, maybe we talked about running single replicas of applications. Sometimes you would want to see what is the recovery time of your app. Let's say you were not running multiple replicas of an application. You were just going with a single replica, and there was a failure. You might want to figure out how best or how quickly you are able to recover. Maybe reschedule and bring up once again, register the proxy, and then start serving data once again. How quickly does this happen? Sometimes you might want to run in modes that are not classified as the best practices, but you would still learn a lot about your system by running that way. So that's something that is should be done, but most probably on staging environments or development clusters, because you would not want to attempt this in production, because these are things you would still learn anyways while you're running it, even in a non-prod environment.
Anything to add, Uma, to that?
Yeah, it's actually a very interesting question. I think you're saying, Patrick is asking, should we implement non-best practices or inefficient practices? So I'm saying the same thing when I say chaos is a best practice, right? It's a must-have. That really means that you introduce non-best practices into your production. That is chaos. Right? So your best practice is that do everything right. So chaos engineering says that break something, don't assume that everything will happen. So the best practice is to have chaos engineering. That means best practice is not to follow always the best practices that you're asked to follow. And as a result of breaking things on purpose or willful fault injection, you will improve your best practices. That means you did follow some non-best practice and that unearthed something, so you tuned your best practices. So I would say he's 100% right, and he's just put it differently. And we are putting chaos engineering as a more polished word, but it's an absolute thing. No one can tell everything will work fine.
I always keep going back to how many learnings I personally used to take from fire drills or even like red team thinking. That was like a very powerful one. But taking a step back and summarizing this is you tend to learn more from failures than from successes, right? So when you fail, there's a lot of learnings there. When you succeed, sure, but maybe doesn't feel as significant. Maybe because also like the loss bias, I think. Like when you lose something, it feels worse than when you win something. I think it's rooted in that. Loss feels like bigger, like, oh, what? My database was deleted? Oh no. Versus the migration just worked. Sure, it's okay. No big deal, right? I think that's the way to think about it. Okay, so that was a good one. Hopefully Patrick got what, well, not what he was expecting, but got something good out of this. Now, I would like us to go into a specific use case, and I keep bringing this one up, the changelog.com application. We are in a unique position to be able to experiment and learn new things in the context of the app that runs all our shows, all our podcasts. That's pretty unique as far as I know. So changelog.com is a monolithic 3-tier application. There's a front end, a back end, and a database. It's single instance for various reasons. Episode 10 has all the details. And I'm wondering if we were to start using chaos engineering practices, which from what I'm hearing, they're mostly targeted towards microservices. I think that's where they shine. But what chaos engineering practices could we use for our application just to see how resilient it is?
I think chaos engineering is as applicable and important for monolithic applications as they are for microservices. Sure, I think its adoption has been increased because of all this paradigm shift to microservices and the fact that you have more possible failure points. The surface area for failures is much more with microservices, but that's not to say that it cannot be applied in principle to monolithic applications. In spite of being monolith, there are some amount of dependencies that you would still have, let's say infrastructural dependencies. We talked about databases being used as part of the stack. It's very much possible that the disks become slow, your writes become very slow. It's possible that you have space getting filled up, you don't have space anymore to write things. How are you going to behave as an application that's probably very read intensive and you are having some problems, but you still have enough in place to keep the users happy while you are able to recover your systems manually? So this is something that you would still check even if you were running a monolithic application. And that's true for a lot of other infrastructure components as well. And when you do chaos engineering, there are two ways of deriving the scenarios to get started with chaos. One approach is a completely explorative approach. You take a look at the system, you identify things, these are the things that can go wrong. Then you start going ahead and doing those controlled failures and noticing your system and how it behaves. The other way of deriving scenarios is to look for data, historic data of what has gone wrong before and what is the most problematic area. How many times did I have to grow my volume? How many times did I have to increase the CPU cores on my system? And when there was a lot of interest, a lot of reads, a lot of traffic, what was the component that I needed to be most careful about, which displayed let's not erroneous characteristics, but characteristics that you would not identify as optimal behavior. And then you go ahead and derive the scenario from there and go ahead and do it. Right. So that pattern is common for both monolithic as well as microservices applications. But the general concept of chaos engineering still applies here too. It's just that the failures here might be more tied to the infrastructure rather than something that you would think of in case of a microservices world, where the dependencies and core services that you're running along with your main business app offer as much food or as much possibility of failures rather than the hosting infrastructure, I would say.
So what tools would we use to do all those things? Is there like a tool that you would recommend that we pick up and try simulating these scenarios or faults, whatever you want to call them?
Yeah, you were asking two creators of Litmus Chaos project, what tool would you use? Yeah, of course, we both recommend.
Maybe not Litmus Chaos. It can happen.
Yeah.
Unlikely, but
If you want to run into real chaos in chaos engineering, don't use Litmus. But if you want to stay organized in chaos engineering, you might choose Litmus.
Okay.
Yeah, the idea of Litmus Chaos is to make sure that we provide a platform, not just an experiment. As I mentioned earlier, chaos engineering is real engineering. You go through managing the experiments, you managing the steady state hypothesis logic, and you keep changing it. You're not happy with what you did last time. So how do you manage it in your system? There are multiple versions of it. We needed a platform in our prior life, work life. That's when we looked for some good chaos engineering tool and started writing Litmus, and it became more widely adopted. Yeah, I would say you can start with Litmus, and Litmus is just a chaos engineering platform. But for you at Changelog, I would also recommend the best practices as, first of all, you need to play the role of person outside the system. Try to discover. Don't assume too much about how your system works. But start with game days. Apply the logic of something will break when I do something crazy, right? That's what is game day. And then that brings some good unknowns, hopefully, in the first day, and then it shakes up your co-workers and your management, and then you start putting a better holistic approach. And then I would also say as a prerequisite, you need to have good metrics or a dashboard even before you apply chaos engineering. Do you have a good monitoring system? Because when you actually do apply, it breaks, but then you need to be able to take care of observing what has gone wrong and what do I do now, right? So it all goes in hand, discovery and reliability metrics, reliability, observability system, all those things need to be in place. And then start with probably the backend, right, and the infrastructure. And even though it's monolithic, you can still apply some service level chaos, such as push too much traffic into one of the services that you use less, but that can cause stress on overall systems. And then there is a lot that you can do when you proactively in your pre-production environment, right? Try to start there and learn, and then go from there either right or left into production or into, you may find something that you can improve on your pipelines. So you can go and introduce these failures into your pipeline, and that might be a good place, right, for the overall efficiency of your DevOps.
So when it comes to starting with Litmus, the Litmus platform, I imagine we would need to have an account, right, on this platform. It's not something that we would run. Is that right?
Litmus is a Kubernetes application. It's not SaaS. So it's a Kubernetes application, completely open source. It's a CNCF project. You take and install Litmus on Kubernetes. It spins up a Chaos Center. And Chaos Center, you can log in and you connect wherever you want to run Chaos. From there, you connect to Chaos Center, and You can then pick up a chaos experiment or a fault and direct that fault towards your target or to the agent, right? You can run it on your existing Kubernetes or spin up a small Kubernetes cluster to run Litmus. And it is quite thin, but it is a Kubernetes distributed application. You can scale it up if you're hundreds of QA SREs are using a single instance of Litmus. It can scale up easily.
Do you install it as a Helm chart? Is there like an operator that comes with its own CRDs? How does it get installed on Kubernetes?
Yes, you're right about that. You do have a Helm chart that helps to install the control plane of Litmus. And as part of the setup process of the control plane, you would go ahead and set up the account. And the account is most probably about the users who's going to do the chaos. And the next part is about the agent infrastructure. This is the environment you're going to actually do the experiments in. So this can be the same place where you have the control plane installed. Uma mentioned that Litmus runs as a Kubernetes app. Or you could have other clusters in your fleet where you want to do chaos. So you would be registering that into the portal. And that is where the operators and CRDs get installed as part of the agent setup. And you can then go ahead and construct scenarios or workflows, as we call them, through the Litmus center, the chaos center, and then they get executed inside the cluster where the agent takes responsibility of applying the manifests, the custom resources, and then reconciling them, and then actually doing the fault injection and steady state validation process.
So I've seen somewhere, I don't remember where, Argo CD being somehow related to this as well. What is that relationship between Litmus and Argo CD?
We use Argo workflows as part of the chaos scenario construction. So we chose Argo workflows for its flexibility to order or sequence faults in different ways. It's a workflow engine at its core. We've instrumented the Argo workflows with some Litmus intelligence. The containers that carry out the steps within a workflow understand Litmus API. So they are used as part of the chaos workflows. The Argo CD part, I'm sure you might have heard of it, more around the GitOps support that Litmus offers. So when we built Litmus, one of the things we wanted to do was somehow weave in the chaos engineering aspects into the standard GitOps flow that people are beginning to use. And people are trying to use GitOps to ensure the applications and infrastructure is maintained in a single source of truth, that is Git, and they ensure that what is on their deployment environments match what is in their source. And there are controllers, also called as GitOps operators, which ensure that your applications are upgraded whenever they change in the source, etc. And oftentimes we see that people who've upgraded applications in their environment or they have deployed new infrastructure want to verify its sanity. And one means of verifying sanity is by performing some chaos experiments along with a specific expectation of what's going to happen. And they already have a hypothesis in mind that they burn into the experiment definition. The experiment has the ability to specify validation intent within it. So people want to do those sanity checks whenever they've upgraded their infrastructure or upgraded their applications. And it was done in a manual way. So we wanted to automate that and provide these users or this persona with a means to run chaos experiments automatically when something is changed via the GitOps operators. That's when we brought about the event tracker functionality within Litmus. So it runs as a separate microservice in your cluster. So whenever Argo CD upgrades your application on the cluster, you have the option of triggering a predefined or a pre-subscribed chaos workflow against it. And that happens via a call to the chaos center from the event tracker service running in your cluster. So that is the relation that we have with Argo CD. And it is true for other popular GitOps tools as well. Could be Flux or Keel or you might have built in something with your own. You might have written up some tooling by yourself using Helm. So you have the option of triggering Litmus experiments or workflows as sanity checks post a standard GitOps operation. And there's another angle to it. Litmus also supports GitOps for the chaos artifacts. So when you construct chaos scenarios, these workflow manifests can also be stored in Git or committed into Git automatically. When you make changes to the chaos workflows in your source, you will have that changes reflected on your Chaos Center as well. So that is another perspective or way of looking at Litmus with GitOps.
Okay, that makes a lot of sense. So I'm starting to form this like mental model in my head of how all this fits together in our setup. I can start seeing the integration points. But what I'm wondering now, Uma, is if someone doesn't have Kubernetes, how do they start even using this?
So when you talk about Litmus, you need Kubernetes to run the Chaos Center, right? Where the control plane of chaos engineering is put together, right? Where the SREs and developers interact with it, and where you interact with the chaos experiments that are stored on a hub or on your private Git repository. All that is running as a Kubernetes application. So if you don't have a Kubernetes environment and your chaos engineering needs is for a non-Kubernetes environment, you just need to spin up a small Kubernetes cluster to host Litmus Chaos Center, and then you can still create chaos scenarios or workflows or experiments towards your monolithic legacy applications or the regular infrastructure chaos, such as any cloud or virtual machines, all that stuff, right? So Litmus does not work just only for Kubernetes, it works for everyone. But we built it as a cloud native application for all good reasons.
What's up, shippers? This episode is brought to you by our friends at Teleport. With Teleport Access Plane, you can quickly access any computing resource anywhere. Engineers and security teams can unify access to SSH servers, Kubernetes clusters, web applications, and databases across all environments. Teleport is open core, which you can use for free, and it's supported by their cloud-hosted version, which lets you forget about configuring, updating, or managing Teleport. The Teleport team does all that for you. Your team can focus on your projects and spend less time worrying about infrastructure access. Try Teleport today in the cloud, self-hosted, or open source. Head to goteleport.com to learn more and get started. Again, goteleport.com.
So this is a very special topic for me. The reason why it's special is because I disagreed with Kelsey Hightower about running databases on Kubernetes, and I learned it the hard way, again, pun intended, that if you run databases on Kubernetes, the database needs to be built for distributed system that comes and goes very quickly. Failures are intermittent and they can take milliseconds, and it can mess up with replication. That's actually what happened in our case when we run a PostgreSQL cluster on Kubernetes. We tried crunchy data and we also tried the Zalando operator. So we tried both. And in both cases, our replica fell behind. The write-ahead log just stopped replicating. And then the master, or like the primary, shall I say, the disk filled up, crashed, couldn't resume, couldn't restart because the disk was full. The write-ahead log filled the disk, the replication got broken. We couldn't promote the follower to be the leader because it was too far behind. So we had downtime, we lost some data. So what do you think about running databases on Kubernetes, Uma? I know you have a bit of experience in this area. That's why I asked you first.
Yes, Litmus is born out of trying to fix bugs when you're trying to run databases on Kubernetes. So I kind of have an opinion that you cannot have an option of not running Kubernetes and databases on Kubernetes forever. 5 years ago, that was not requirement. 2 years ago, people thought it's very, very difficult. Now, I think there are mixed opinions. There are people running databases on Kubernetes. There is a good active community, data on Kubernetes community. Things are improving, and it is an evolving subject, and tools are coming in. Databases are also changing, right? So the stateful sets are the root elements within Kubernetes that are enabling distributed databases. But at the same time, there are storage elements that are being built or improvised for running databases on Kubernetes, right? For example, my earlier project, OpenEBS, which is still a popular subject in this space, is having the concept of containerized storage, right? So you try to consider the storage as a container, an element that is built for running data on Kubernetes. And similarly, there is an element of local PV that is started by Kubernetes itself. And there are solutions being built on top of local PV. What happens when this moves or this goes down? So I would say there are people who are running data on Kubernetes, but because the infrastructure also becomes a microservice, you need to understand that there are more failures that can happen, right? So storage is not guaranteed to be running in one place. It can just move around. And how do you actually handle that situation, handle your application to do that? So just assume that it's not just your pod that can just go off and come back in. Assume that your storage also can go off and come back in, right? So this is a natural thing. And that's why your application just need to be aware of such scenarios and build it for more resilience. And chaos engineering as chaos first is a principle that can definitely help in all these things. Mm-hmm. So we will hopefully in a few years from now, there will be questions like, oh, we thought data on Kubernetes is not ever possible, but I see many people running it. Right? That could be what will happen, is my opinion.
I would agree with that. I think there is a process of, as you mentioned at the beginning of the interview, it's evolving. So I think the storage, the data layer is evolving on Kubernetes, but also the networking, I think it's evolving. Because in our case, the one that I mentioned earlier, it was networking, high network latency, packet loss, very high packet loss, which just messed up the replication PostgreSQL. So it wasn't specific to any operator, by the way. It wasn't Crunchy Data's fault. It was not Zalando's fault, the operator themselves. That's what I'm referring to. It was just the network was just messing up with the PostgreSQL replication. That's what the problem was. In other cases, for the app itself, when we had a 3-node Kubernetes cluster, by the way, have a single node one. I know it's very contentious, but guess what? It works better. So reality says, and the practicality says it works better. The point is, when we had 3 nodes, those volumes that should have moved around, the PVs, they didn't. They were stuck and they couldn't get unstuck from the node that went away. And because they remained in this stuck state, couldn't detach, they couldn't be reattached to other nodes. So that was a bit of a problem as well, which hit us. I know that things improved and they evolved, but I don't feel they are there yet, especially if the database was not built to be a distributed one from day one. What I'm wondering now, Karthik, is if there is such a stateful system, which was built to be distributed from day one, and it understands that and it's like in its DNA, is it easier to run it on Kubernetes? I'm thinking maybe a message broker that was built to be distributed. It still has some state, but it works as a distributed system. What do you think? Does that make it easier?
Yes, I think to a great degree it does. But the network problems are not going away anywhere, Gerhard. So if you take a look at the Litmus Slack channel on the Kubernetes workspace, network latency and network loss are probably the most popular discussion items. People are trying those experiments much more than they're trying other experiments. So it is something that will continue to be there as the network also evolves with storage and all the other concepts in the cloud native world, we will still have to address these network problems once in a while. So message brokers is a good example. And in fact, when we try to build some illustration for application-specific chaos experiments within Litmus, so application-specific chaos is a category of chaos experiments in which the experiment business logic has some native checks, health checks that are specific to an app, and they also consist of certain faults that are native to a particular app. And these could be just the standard faults applied within an application context, or there could be some faults that are very native or very specific to a given application type. So the first application-specific experiment that we considered was Kafka. And we have some communities that are actually trying out Litmus against Kafka. Strimzy is one of the Kafka providers who we are speaking with and trying to collaborate on to identify good scenarios that can be used as part of testing. What is relevant in the message broker world is, let us say you have some very intelligent message broker that is capable of handling message queues and doing failovers and doing elections and things like that. Because here also there is some amount of state involved. So you have storage at play, you have network at play, you have all these things. One of the scenarios that we got started with was killing a partition leader, which could also be a controller broker. And then you have a series of things happening. You have re-elections happening. You're basically trying to speak to Zookeeper, and you're trying to ensure that the failouts happen quick enough so the consumer's message timeout is not breached, or session timeouts are not breached. So these are things you would still want to find out. These are good experiments you would still do in these kind of environments. Differs from infra to infra. When we did this Kafka experiment on AWS with the standard storage class, EBS-based storage class with the AWS CNI, versus when we did it against GKE with the GPT-based default storage class and the CNI there, we saw there was a difference in the recovery times. We saw that we needed to set different timeouts at the consumer for the sample message stream that we were doing. And this experiment was a simple pod delete experiment. You will have the need for chaos engineering in these environments as well, both to learn about the system as well as prove some hypotheses that you might already have around timeouts and such settings that you have. So to come back to the earlier question, will data on Kubernetes become simpler when our application architecture evolves to becoming distributed? Yes, I think that will definitely help. And I'm just trying to tie together chaos engineering there. The adoption of data on Kubernetes can be accelerated, much in the way general Kubernetes adoption itself can be accelerated through chaos engineering. And there are folks in the Litmus community, and I'm sure there are other projects speaking to such users as well, where they want to use Kubernetes in production, but they're not really confident about doing so. And they want to set up staging clusters, test out a lot of failures on the Kubernetes control plane itself. You have your schedulers or controller managers going for a toss. You have etcd going for a toss. And then you're also trying to see what happens when you kill pods. The multi-attach error issue, as we typically like to call it, the volume not getting detached from one node and therefore it doesn't get attached to the other node. This is something we found very early in OpenEBS using a chaos experiment, and something has come up in the 6 storage world to fix it today. And OpenEBS has taken those fixes on board. So I think both the application architecture, the data architecture becoming more distributed, as well as evolving chaos engineering practices will ensure that the adoption of databases into Kubernetes, as well as the general Kubernetes adoption itself, will increase.
I think the most important point that resonates with me that you've made, Karthik, is around the different platforms having different recovery times. I think that's really powerful because if you're, for example, as we are running on Linode, we cannot apply the same approaches that someone may be running on GCP or someone running on AWS. Infrastructure matters a lot. So then how do you know how does it behave in your case? Well, one solution would be to maybe apply Litmus Chaos and see how it behaves in practice. Also, not to mention that you do upgrades to your Kubernetes. Things improve most of the time, but sometimes they get worse. So how do you find out what got worse before rolling in production and everything just hopefully failing over, other times just failing in unexpected ways? So how do you preempt some of that? And we all know that as much as we want to be confident from our staging experiments, the best failures happen in production. So as much as you can try to preempt things in staging, until you go into production, you won't see it. So maybe trying to generate production level load if it's possible. It's not always possible. That would help. So as a listener, if I had to remember one thing from this conversation, what would that be, Uma?
Yeah. So the last stage of reliability is to be able to confidently generate random triggers after you apply every change to your system in production, right? So you upgraded, you have good CI/CD system, and you applied the change in production, but also extend that CD to create a random fault because of that change. And if you are so confident, that means you're testing well. And it takes time. And chaos engineering, starting in some form, either in pre-production or in QA, it all helps reaching that goal. But always remember that unless you are doing that confidently, breaking things confidently, your systems are not reliable. You can just assume that they are reliable, but they're not. So use chaos engineering as a friend.
What do you think, Karthik? Would you agree with that?
Doing chaos engineering in production is really like the ultimate stage, the nirvana of a very mature practice that you set up in your organization. So start small and explore a lot of failures and establish a culture of continuous chaos at all levels. Chaos has become more democratic, more ubiquitous nowadays. The philosophy of chaos is sort of percolated to all personas, like Uma said earlier, from developers to QA engineers to SREs. So go ahead and perform chaos, and then you will be able to sort of confidently deploy your applications and sleep better at night.
Thank you very much, Karthik. Thank you very much, Uma. That was a great thought to end on, a very powerful one. So yeah, go forth and break things. That's what we're saying in production, by the way, because until you do that in production, it's okay, but it's not great. So for the proper challenge, the ultimate frontier, as some call it, go in production and break things and see how resilient your system really is. Because those are the real failures that matter, or the only failures that matter. You can learn from all the others, but the production ones are special. So the sooner you get there and the sooner you start applying these practices, as Uma and Karthik described, the better off you will be, the more resilient your system will be. And system doesn't mean your stack. It means the value that you deliver to the people that use your system. Thank you, Mel. Thank you, Karthik. It's been a pleasure. I hope to see you again soon.
Thank you, Gerhard.
Thank you.
That's it for this episode of Ship It. Thank you for tuning in. We have a bunch of podcasts for developers at Changelog that you should check out. Subscribe to the master feed at changelog.com/master to get everything we ship. I want to personally invite you to join your fellow changeloggers at changelog.com/community. It's free to join and stay. Leading, on the other hand, will cost you some happiness credits. Come hang with us in Slack. There are no imposters. Everyone is welcome. Huge thanks again to our partners, Fastly, LaunchDarkly, and Linode. Also, thanks to Breakmaster Cylinder for making all our awesome beats. That's it for this week. See you next week.